Today I'm going to cover the introduction to machine learning. Okay. Oh no. So the presenter, myself, my name is Junyoung Park. I'm assistant professor at UT Arlington. So my research area is a smart and sustainable building, which you utilize a lot for machine learning techniques. So I'm glad to share my knowledge about machine learning as much as I can with respect to the building energy domain. And this contents and these all Friday session is available by two other presenters or instructors who helped me to formalize the session, who is my PhD student, Stephen Tanner McCullough, and Dr. Jessica Izuma, who's another PI who helped on these contents. So, very first question, where are you now? How far from Arlington, Texas? Is anyone want to compete with me? Where are you now? Just quick question to all. You can say with the voice or you can put it in the chat. So let me check chat now. El Paso, okay. From Dallas area, it's about like 5-hour driving. Atlanta, Georgia, okay. Anyone else? Outside of US? Peru, okay. Pakistan, okay. Anyone else try? Virginia, okay. Anyone else? Okay, so I think I'm quite far away from Dallas because I'm currently outside of US now, but I guess I'm closer to Dallas compared to Pakistan. So currently I'm at South Korea now. So which is 6,850 miles from Arlington. And it also has 14-hour time difference. So currently here, as you can see on my laptop, it's 11 p.m. So be mindful about my condition because usually this is my kind of nighttime. But I tried to put myself in Arlington, try to teach this lecture. And I'm very, very, very glad and excited to teach this topic in this very, very late night time. It'll be more fun. So what time over there in Pakistan, Zahid? Just out of curiosity. Did you use your chat? 7? Okay, that's not bad. It's you have a good schedule to follow this lecture.
It's 7:08.
Huh? What was that?
Sorry, I
10
missed
a.m.
your question.
No, I just asked what time over there. So it's 7 p.m. So it is a good time to follow this lecture. That's all. And 10 a.m. in Atlanta, I guess. So, all right. So the today's lecture will consist of 3 main parts. The very first part, lecture content 1, is Introduction to ML, which is right now we're doing it. So in this content 1, we're going to clarify the objective of this bootcamp with respect to the ML, machine learning. And then I'm going to like explain the introduction to ML. And I would like to summarize or some highlight or explaining the importance before learning ML algorithms. So kind of bridging to the actual ML algorithms to the gentle introduction slide. And contents 2, which is ML algorithms. So after 15-minute break, we'll go through the supervised, unsupervised, and reinforcement learning algorithms. And note that these are like kind of pick out the basic and easy to follow algorithms so that your journey is easy to start the ML journey. And the last component is the coding practice for ML, which is the after lunch hour. So we'll use the building energy data for learning classification algorithm using KNN and decision tree. Okay, so these are 3 main contents that I'm going to deliver today. And these 3 contents are divided into the different lectures. All right, so before dive into the objective, I asked ChatGPT, and I think everyone knows ChatGPT, right? So I asked ChatGPT, what is the best way to learn ML? And the ChatGPT is basically answer almost exact that I would like to highlight in this first lecture. So they said the very first one is start with the basic, and the basic includes whatever you are familiar that are linear algebra, calculus, statistics, and probability. And those basic math skills are really, really critical to learn machine learning in your journey. And number 2 was take online courses like this course as well, including this bootcamp courses. But you can see many, many other machine learning courses from Coursera, edX, Udemy, and these courses generally require your programming language like Python or R. And these are 2 popular programming languages. And I think I started with MATLAB, but MATLAB is not open source. It's licensed in education, is free, but once you go to after graduation, you may not have the free license to on a MATLAB. So I highly recommend start your journey with the Python or R. And for this bootcamp, we're doing the Python as our main programming language. So the third contents, the coding practice will utilize the Python as your main language. And they said it recommends books and research papers to follow up the most recent algorithms. And number 4 is, I think, very important, practice with real-world data set. And the real-world data set here means also you can download the open data set and also the area that you are interested in. I think most of them are here are geology or water resource management or building energy or archaea engineering folks. So for those who are interested in archaea engineering or building energy, the building energy data will be the good target or good data source to work on. And really having those real data sets, then you have more fun and you'll be more into it to learn the machine learning algorithms. And the 5th one is I also like this. Join a community like Reddit or Stack Overflow or GitHub. Those you are not coding from scratch. You're not coding the machine learning algorithms from by yourself, but you will probably or almost highly likely use the already built libraries, and even just utilize those already built-in library is quite hard. So you might need some help from those community to for your coding tasks. So knowing where to search and how to search those algorithms using those community is very, very important thing. So I would say those all 5s are important. And I extremely like the last kind of sentence. So learning machine learning takes time and effort. Start with the basic, be patient, keep practicing, good luck. So that means like just taking this couple-hour lecture today won't be enough. You have to like spend your own time about if you are interested in this field. This lecture is literally just starting point of your machine learning journey. Okay. So having said that, our bootcamp objective is learning ML, machine learning, is generally by taking a course or courses. So certain algorithms, for example, like artificial neural network or convolutional neural network, they have their own designated courses to learn. So check your institution's course list if you are particularly interested in a certain course. And this lecture will not cover all the algorithms that you need to learn. Researchers, even nowadays, they currently develop very, very actively and release their algorithms in various communities like Reddit or like GitHub or Stack Overflow. So checking out those state-of-art algorithms is very, very important. So that's why links to the ChatGPT's recommendation, join a community, because you cannot learn everything. Something you're interested in, you have to put yourself on those community and see what's going on over there. And also everyone develops advanced algorithms upon the basic ones. For example, you may have heard the decision tree, and having those decision tree, the advanced one is a random forest. So understanding the decision tree is important step to learn about the random forest algorithm further on. So just starting with the very simple basic one is sounds like easy, but it's very, very important step to further you identify what you want to do to know. Okay. So that's kind of our first objective. And we'll introduce some basic algorithms to begin your journey. So for example, KNN algorithm, K nearest neighborhood classification, and decision tree, and um, K-means clustering, and the reinforcement learning technique. Those are very, 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 I will go through very basic steps on those things so that my intention is make you guys interested in this ML so that you, after taking this course, you are devoting yourself or spend your own time to learn and study, self-study by yourself. And really a lot of self-studies are required. And if you're interested in this and if you want to learn on this, and do not expect we'll cover every algorithm today. We'll introduce one or two basic ones, just like said, for your self-learning. Okay? All right. Before starting that, any question on your objective and today's lecture? Any concern and feedback so far? Tanner, do we have any chat questions?
No chat questions.
Okay, sounds good.
Excuse me.
Yeah,
You mentioned about three communities that like we can join. You said Reddit and Stack Overflow, and what was the third one?
the GitHub.
GitHub.
Yeah,
Okay. All right.
GitHub. Yeah. So people put their algorithms and their papers sometimes, their own repository. And there are many others, but these three are maybe first you can start with. Okay. Thanks for your first question. All right, so let me ask you some questions. Can anyone tell me what is machine learning and what machine learning algorithms do you know? If somebody put in a chat, please speak out, Tanner, or if you can just turn on your microphone and just speak out, that'd be better too.
I'll let you know if a question comes up.
Yep. Just try. I just want to know because machine learning is everywhere in use. Yeah.
I think
Yeah. Go ahead.
a simple understanding is making your computer to understand um, uh, um, or to learn how human being do things or behave or kind of something like that.
Nice. Good try. What was your name again?
Joseph?
What was your name again?
Joseph
Joseph.
Nadi.
Yeah,
Yes.
great. Thanks. Anyone else try? What algorithms you have heard or you already know? Right, I guess this is a good signal because we're going to cover these. So you will learn and then you can answer this after this session, and that'll be the good learning progress, I think. All right.
One
So let's
one person had mentioned that so Joel posted in chat. I did some brief research on linear machine learning last semester. I'm still a little confused about it though.
Okay. Thanks for your opinion, Joel. So hopefully this will, after taking this short lecture, that will clear up. Otherwise, we can chat after this lecture too. All right. So here's are some old sayings from very established researchers in computer science domain. So Alan Turing in 1950, instead of trying to produce a program to simulate the adult mind, why not rather try to produce one which simulates the child's? So see how childs learn the new things and not just programming everything. So just like there's a rabbit, we're not, I mean, we sometimes explain how the rabbit look like. There's long ears and short tails, but rather than that, just I have a 3-year-old daughter and she saw so many rabbits from the news, from the media or from reality, and she realized or learned, oh, this is a rabbit. If that looked like a rabbit, then she just naturally understand or like say that is rabbit. Nobody or I didn't or my wife didn't tell my daughter, hey, this is a rabbit. If there's a long ears and short tail and white bunny or gray bunny, these are rabbit. We never tried to do that. That's almost impossible to all the things in the world. So they just see it, then ask it what it is, and we repeat it. It's a rabbit. It's a rabbit. Then they understand that's a rabbit. So that's more like a learning procedure. So Alan Turing said, produce one which simulate the child's learning, like skills or something like that. That's what Joseph's answered on this. So another like old saying is field of study that gives computers the ability to learn without being explicitly programmed. So it's same along with the previous saying or previous sentence and also the Joseph's comments. So learn without being explicitly programmed. So we're not telling how to do it, but just giving the machine, giving the computer to learn without those hard-coded on the learning procedure. Okay. And more recently, the professor from Carnegie Mellon, Tom Mitchell, said computer programming is set to learn if its performance on a task improves with experience. So he just pointed out or emphasized the importance of experience itself in a machine learning, because really having the enough data and experience the enough data-driven way, the machine or algorithm to learn how to classify or regress on their inputs. So these are some old sayings about what is machine learning, okay? And I would like to introduce the IKW pyramid. So here, the IKW, as you can see in here, it's a data, information, knowledge, and wisdom. So it is starting from the data. So data is really fact, or which by themselves has no meaning. So let's say you are like reading a letters and it's a data, it's a textured data, or it's whatever data. Currently there is no meaning, but just it's a fact, or just some simple truth, simple like letters. Now the information is that which leads to understand the meaning we assign to fact. So now you're reading those letters and you have some information to understand these facts. That is information. And once all the information are the synthetically aligned as an orderly, then we can say it's a knowledge. Like, for example, a couple paragraphs or a couple pages make up one book chapter to understand that, or one book to the knowledge. The last thing is a wisdom, which is insight, the appropriate application of knowledge. So you read a book, then try to behave based on that book, that the knowledge or the information that you learned from the book. That's a wisdom. That's your essentially insights on those data. Okay. So really, ML tasks are from data closer to wisdom. So we're having the raw data everywhere, and then we process this data to information, knowledge, and wisdom. And we're striving to wisdom, but that's like very, very hard, challenging task. If you can make a data to information, that is a good enough, or data to knowledge, that's excellent. Data to wisdom, it can be like published in the Nature or somewhere else. So these are the ML tasks that we are trying to strive in the developing machine learning algorithms. Okay. So any question at this point? No question? Okay. So here's my question. Then these days machine learning is popular. So like very, very funny story about when I'm doing my PhD, everyone say, hey, if your PhD dissertation has no data-driven or machine learning, then you will not pass. So it's kind of funny joke that 10 years ago or 20 years ago, in almost every engineering domain, they said, if you have to put micro or you have to put simulation in your dissertation. But these days, you have to put machine learning or data-driven approach or data analytics in your paper. So why do you think machine learning or artificial intelligence is so popular these days with respect to this like DIKW pyramid? Can anyone have any guess or opinion?
My own understanding is that in this in this our day of a lot of information data, and this data need to be processed. And as a human being, we are limited or confined to what we can see in a little world. But with the aid of programming and AI, a lot of information can be processed in a little time.
Right. So you're exactly true. So I would say the most important improvement these days is we have a lot of sensor networks and a lot good computing power system. So for example, your cell phone keep collecting all the GPS data set or acceleration, or your building or your car, your house collects the temperature data or whatever data. So everywhere we buy smart products. And that smart product is they're highlighting that we have this sensor, and we have this storage. We're collecting this amount of data. So because of that data collection is so easily available, so big enough, we can start this ML task journey. So because data is the very starting point of ML task. If we have no data, for example, like 50 years ago, data was very, very limited. Our house has no smart devices, or our car has no smart devices. Our car was just press the Excel and just go. That's all. But nowadays, it has so many sensors, and that sensor is literally the data. And newspaper, we saw the newspaper. These are all the letters, facts. But once the newspapers are digitalized, archived in a like computer format, then now it's a data. Then we can process into information, knowledge, and wisdom. So, like you said, Joseph, because of we have so many availability about those big data, that's the good starting point of or why it sparked the notion of the ML tasks very popular these days. Okay, so any question? Yeah, go
Is
ahead,
there any
please.
downside on this ML, AI?
Yeah, of course. I think the downside is the first one is a privacy issue. Big Brother, everyone like monitored. So the privacy agreements and these should be protected. At the same time, from our own domain, like for example, my domain is a building engineering. So when I was doing the research related to text mining in the building maintenance, one of my research paper was talking about people like writing about their complaints. Oh, this building is too cold. This building is too hot. Or I can smell really bad thing in my room. So there are so many complaints text data. And then previously, before the AI developed, like manually people read it and then assign the people to the HVAC engineer or I mean heating, ventilation, and air conditioning engineer or right type of engineer and assign those people to work on. But these days, they are automatically processed by machine learning algorithms, and then they will replace the physical engineers using the fault detection algorithm or diagnostic algorithms, and so on. So they might like kind of stealing or replace the jobs that we conventionally have. But at the same time, like when the the car industry was starting, all the horse riders or those people are complaining, don't steal my job. But look, because of car industry is booming, we have so many things like designer for car and the car navigation system or the car related industry, which is another like big like booming or change the paradigm of the industry in our domain. So if you ask me, is it only bad thing? Well, I don't know how we will prepare on that. So if we are preparing well on that, we'll create another new industry or new job field on that. But otherwise, like we will lose our like task by AI. Am I answering your question, Joseph?
Yeah, I think well, you answered the question, and because that was the second question I was supposed to ask, but you answered everything. That was pretty good.
Yep. Any other question from other students? Nothing yet, Tanner, on the chat?
I don't see anything.
All right, all right. So let me continue. I'll try my best to make you guys interesting and they give some voice on it. All right. Go to next. So we keep saying that data is super important and the very, very, very important starting point of ML tasks. So how do we understand data for ML? What kind of data can you see here? Can anyone answer? What type of data you can see?
Data by age.
Data by age, and age is string or numeric? Age is numeric, right? Numeric. So there are numeric data in age, motor value, and we have some classification in gender and policy type and preferred channel. Some string values on occupation. That can be also some classification. We also have ID, which is ordinary values. So we have to see first those data types. We might have text data, date, binary, ordinal, category, and numeric data. So these are all the data types and features we can think of. So feature is any measure derived from data that be used by the machine learning algorithms. So raw features is raw data sources, but you can also derive features like flag, excuse me. Derive features here means flags, ratios, mappings, aggregates, and others. So let's back to our raw data source. For example, occupation. If you wanted to know like some only by lab tech, then just put the flag on for the lab tech and flag down all the other job field outside of lab tech. Okay. And maybe age is like ratio values or some range values. So age range by less than 20 and over 20, something like that, or in between 20 to 30, 30 to 40, 40 to 50. So if the ML algorithm just utilize the raw data source, then it's a raw age. But if you are thinking of that's too much, the categorical of the age by their range is more beneficial on your algorithm, then you can make a categories of your age. Same thing for model values and policy types and reference channels. So we are going to almost cover the raw data features, which is by the raw data, but just converting those features, the raw data into feature is super, super duper important in the machine learning task. And here's the examples. So let's say how to understand this image in your brain. Can anyone say about a few words about when you saw this image? What can you think? Or how to understand this image in your brain, not in computer.
I think generally when we see the color blue in nature, like in this example, we can tell that it's a sky and some sort of lake. And then based on that, we can infer, like we can conclude that it's some sort of forest and a mountain range.
Yeah, you're Joel, right?
Yes.
Good, good. You're almost like a computer thinking now. Any other? How can you procedure this image in your brain? Let me rephrase the question. How can you process this image in your brain?
Yeah, for me, what I can process from it, the river flowing between two high points where you have vegetation, the green section, trees, and the pointed section, which looks like a Rocky Mountains. And by the right, you have a lot of vegetation, green with the green that express vegetation, and towards the shore you have sand, look like some kind of beach resort, stuff like that.
Nice, nice, nice. Thanks for your input. So let's see. So I think there are many, many different ways to process these image in the computer. Like what you said, Joel and Joseph, it's more advanced way, like mimicking the human procedure. But what they firstly start is basically they make a grid like this. And then I cannot draw very, very, very thin lines, so I just made it this way. But oops, this point. Think about this point. If I have very, very, very small cell, I would say, that cell contains the three information, RGB, red, green, blue, right? And then they put 141. So every like color has that three components, RGB. So this one portion has 141 red, 35 green, and 31 blue. Just I made it up. And then it depends on how you procedure on it, but here's an example algorithm is they make an average of these three numbers and put it here. Now, this image is converted into a matrix or series of numbers in this grid. So just converting this image data, which human can understand, put it into machine readable or computing, like computable format, which is a series of numbers, and then we can work on it. So this is more on features that you can define it. Okay. Any question on this kind of procedure or how computer understand image data?
How did they come about the 141, 142, 143 red, 35, 36 green, 31, 32 blue?
Yeah, so it is really defined rules. So let me want to keep your ink annotated? No, discard. For example, if I search, oops, why my keyboard is not working? Color palette, color search. No. Color sync utility. No, color finder. No, not this one.
What I mean, is it like a standard procedure?
Yeah, it's a standard procedure. I just wanted to show some apps that I'm using. So basically, it is agreement in the visual artist or computing visual artist. So every color has these three components of RGB. So let's say like this one, and then go to like color, more colors, red, green, blue. So if I put, I don't know, I just made it up this example. So 141, 35, and 31, the color is like this. Did I answer your question? Joseph?
Yes.
Yeah. So these RGB is really defined by it's, it's just whatever they define. I mean, the color is mixed with RGB. Okay. And more advanced feature engineering is from RGB image, they can see only depth of it or surface normals or occlusion boundaries or segmentation mask. So whatever you are interested in or whatever you want to focus more on, then you can select different types of feature engineering. You just pick out whatever you want to. So for example, maybe segmentation mask is very, very beneficial or very, very helpful to detect the shape of the unique thing in this image, right? For example, these keys, I would say this key or what is this? It's ice. And this is more on cups, glass cups. This is I don't know, whatever shape, the flower shape things. Okay. And if you want to know, if you want to develop like tree detector algorithm, then you might want to masking up these tree portion to make it, right? That's how like vision algorithms or computer vision people are coming up with advanced feature engineering, okay? And how about building energy data feature engineering? So here's the one building energy consumption data. So from 0 kilowatt to 200 kilowatts. And you can see from 1 day, 2, 3, 4, 5, 6 days, every day repeating. So what are the important features to express in this data set in building energy data? Can anyone try?
Can you repeat that? The important
Yeah,
features?
so yeah, if you see this building energy data or profiles or patterns, what is the important features you want to pick out from this time series data, I would say?
Could it be like the peaks where the
Yeah.
energy consumption is the highest?
Yeah, the peaks. That's good, very reasonable, and very, very nice insights. Anything else?
Where you have uniform energy usage.
That's good. And maybe the duration of that peak continues, right? That length will be the important features as well, geometrical features. So this paper is coming up with these energy consumption profile with only 4 letters, A, B, A. And this day is ABBA. This one is ACBA, ACCA, again, AAA, ACCA, and so on. So every day, it's not just like 24 points or more than 8,500. I mean, more than that points, but they're coming up with only 4 letters because this is important features that this building energy domain researcher wanted to know, because they might be useful for understand building energy consumption patterns. Each day, what was the consumption pattern? So because Saturday, Sunday, and Tuesday, this was unique Tuesday because it's a January 1st, which is holiday. So that's why it shows AAA. And if you know the ACCA, then you can understand these days are super important about the energy supply. So now each day energy consumption profile can be simply expressed by features. For example, these days are CCC, CCCB, which is all day long, very, very high energy consumption pattern. I don't know what day it is, but you can check out if these CCCB feature going on, then that is a kind of problematic days that you need to check out. There might be something wrong on your building energy consumption pattern. Some devices are overcooling or overheating like throughout the day. That's a super important problem. You have to check it out. So converting the raw energy consumption pattern data into those 4 features will be beneficial for computing algorithms, machine learning algorithms, to detect what was a wrong day, what is a good day, what is the best day, and so on. Okay.
Someone
So
asked
that,
in the chat.
Mhm.
I think you've kind of already gone over this a little bit, but someone asked, from the numbers, is it able to find the type of features that you're looking for?
So the question was the numbers can be
Yeah.
features. Okay, yeah,
Yes.
that number can be features. But the point here is this paper or this researchers try to make the feature as simple as possible to make a better ML algorithms for the important features to understand the shapes. Okay. So that's about the feature engineering, how to convert the data into the features for the beneficial way. And before we're going to the each ML algorithm, so here's some important notes about the ML. So a good ML model should provide a good generalization, and that is no freelance theorem. It's very important. There is no free thing. You have to try it and then see the results, change the parameter, run it again, and see the results. Keep doing and doing and doing and try and error to find the good generalization, which is a good ML algorithm. Because we want to avoid these two types of bias. One is underfitting, and I mean, these bias can lead to, one is underfitting and one is overfitting. So underfitting is model to simplistics, relationships not captured well. Overfitting is model is too complex. Model becomes very sensitive to noise. So here's an example. There's a age and income data set. And for example, age 21, 24K, and that point, the first point, age 32, 48K, okay? Do you think this is underfitting or overfitting? What do you think? Is it underfitting or overfitting?
Underfitting.
Yeah. Why underfitting?
Because I feel like the points are a little too far from that line.
Yeah. How about this one? Underfitting or overfitting, Joel?
I think that would fall under overfitting.
Yeah, overfitting. So it's really capture every data points, right?
Yes.
So go back to the definition here. Underfitting, model too simple, relationships not captured well, which is this one, right? Too simple line. This is just ax plus b, y equal ax plus v. But this is too complex to capture the relationship, too sensitive to the noise. This will be a good fit model, good candidate, right? It is not very complicated, but not very simple, but captured good generalization model. Okay, this is a good fit model. So here's an example question. I think we don't have enough time to cover that, but let me just really quickly go over. So there is a model 1 and model 2 about outcome default repay based on the if and else statement. And which of these two models will generalize better to instances not contained in the dataset? Propose some bias that would enable a machine learning algorithm to make the same preference choice as you did in part A. Do you think the model, question number C, do you think the model you rejected in part A is overfitting or underfitting the data? So there is a very complicated model, which is a model 2, and somehow a simple model in model 1. So model 1 is likely generalized beyond the training dataset because it's simpler and appears to capturing the real pattern in the data. And if you choose between a number of models that perform equally well, prefer the simpler model is always better. If you coming up with the Tuesday lecture, it's Occam's law, always go to simple if both having a same performance rate. And more on that, model 2 is overfitting the data. It tries to capture everything in a training data set that might result in some problem in the the testing data set. Okay. So here's a bias and variance trade-off in ML. So bias is error due to assumptions. So high bias, you have so many high bias on your data set, then it will be the underfitting. And model does not capture sufficient characteristic of the data. On the other hand, the variance is error due to sensitivity of model. So high variance here means overfitting. Model captures noise in the data. So we have to balance between these bias and variance trade-off in ML models to identify a good fit model. Not to overfit, not to underfit. Now the question is, how can we evaluate and how can then we improve the performance of a given model? That's the main question. How to identify or how to identify the good fit model. Anyone try? Any idea? Okay, so let's move on. So the answer is we have to split our input data. So let's say we have data of this one, occupation, age, loan salary ratio, and outcome is default or repay. That kind of data set. We got 100 rows or 100 data points. Now we have to split this data set into, firstly, we have to put the test data set, which is hidden data set, never seen data set as a side. And then let's say from the 1,000, let me redraw it here. Say we have 1,000 data point. Let's say 1,100 data points. And we have to select 100 test set. This is a pure data set, pure test set that we will never use for our training and validation approach. Now we have to split this into 700 and 300. Okay. So we're going to use that 70% of the data for training and validation for 30%. And training is just for training purpose. Validation is just for the compare models. Test is see the accuracy, no model tuning anymore. Whatever we coming up with the right model that we're going to use this test set. Let me be very clarify and slow on this task. If we giving the model complexity more complicated more and more, then the training error will go down. But what kind of problem that we'll have if we go in here?
The generalization error will increase.
Yeah, and also the overfitting, the graph that you saw before. That curve was very, very complicated. That was perfectly working well on training set, right? But if you put some never seen kind of wild data set, then the model was trained too much on this 700 data points. So it may not good as your training set results on your testing set. Was it clear? I can repeat that.
Can you please?
Yeah, sure. So let's say this one. This was overfitting. Do you remember this? And this was underfitting, right? And if we go more complicated model, very, very complicated model on your training data set, which is a 700 data points, if you keep learning and learning the model on those 700, then your model is perfectly doing well on this 700 data set, right? So that means your training error on your training set is really decreasing the error is decreasing by complicated model. But highly likely, if you are too much on the 700 training set, then if you put your model into your like hidden or never seen this 100 test set, that might not work pretty well because this model is too much onto this 700 data set, which caused the generalization error on the training set. Clear all now or still?
Yeah, it makes more sense now. Thank you.
Yep. How about others? Everyone good on this explanation? Tanner, can you put yes or no on a chat and see how many thumbs up?
Yeah, it's clear.
Clear? Okay. So now it's it passed the midnight. So let me stop here and give a break, and then let me continue from this points, okay?
Hey, Park, I have a question for you.
Please go ahead, please.
Yeah, I have a question.
Yes.
If presently I'm an environmental engineering PhD student, if I want to build a career on the modeling aspect in order to enhance my career, what direction would you advise me to go into, like where to study, how to get my resources in order to like be a top-notch? Because whatever I'm doing, I want to know it perfectly.
So you mean the modeling part is more like a data scientist?
Yes,
Okay.
in environmental.
Yeah. So I think obviously as a civil or environmental engineers, my degree is a civil engineering, for example, and I choose my career path as academic career as assistant professor, but one of my lab mates who are doing very similar path as mine, he is now a data scientist in a startup company. He got some offer from the bigger company, but he would like to pursue his own company to work on it. So whatever I observed from him was he tries to build up his coding and his general machine learning skills. Obviously, that's very, very, very common skill set these days in engineering PhD students. But at the same time, he tried to publish the paper with more advanced algorithms. Even he can pitch his paper out the CS communities about his ideas. But at the same time, we're not the coders or we're not the programmers. We're not compete with them. You have to see your environmental engineering like expertise or that your own like backgrounds, how that is fit into the data science domain. That is more important. So in his case, he wants to like see how machine learning can apply to the demand response, which is a building energy distribution systems.
Okay.
So he tried to like speak out that machine learning, like the machine learning, the algorithm itself can be developed by the building energy data. He kept emphasizing that. So from the computer science domain, it was very interesting because he understands most of machine learning terminologies and the algorithms, but at the same time, he can bring the building energy data sets to the machine learning domain. So it's a very long answer, but my really important advice, even for my PhD student, you have to have your own backgrounds that you can bring it to other domains that nobody can compete with you.
Okay.
Does it answer?
Okay, makes sense.
Yeah. So basic skill set you have to have, but at the same time, you have to have your own storyline from the environmental engineer perspective. Okay. So I got the question from Zahid. So I think that's why I decide to repeat this explanation again. So let me share my screen. All right. So Tanner, can you see my screen?
Yes. Yeah, your screen's coming up fine.
Yep. So let me repeat here. So bias, error due to assumptions. So high bias means underfitting, like this graph that Joel picked out. And variance, error due to sensitivity of model. High variance means overfitting. Model captured noisy in the data. It's too complicated. Okay? So these are one bias and variance error. So we have to balance between bias and variance errors. So how can then evaluate and improve the performance of a given model? That's the main question that we have. So the main answer is we have to split our input data. So let's say you got 1,100 data set. You have to put that 100 data set into the test set. Let me repeat again here. So your input data was 1,100 data points. Whatever you randomly pick, that 100 test set should be pure, never seen, should be used at last end. Okay, now you have 1,000. You can split into 700 and 300. So 700 on training set and 300 in validation set. Okay, so this blue line, training error is keep decreasing by increasing the model complexity. This means if you train your model over and over on this 700, then your error is going down because you are very, very good at your training set. It's overfitting, but it has some generalization error once you go to this test set data set. So your role is somehow identify when to stop. What is the best in terms of good fit model, okay? So training is only used for train. Validation is compare model. Test is estimate accuracy. So let's move on. So first iteration, you have this amount of test set and training set. And the second iteration, you have this amount of test set, training set, test set, training set, test set, training set. So in here, this is not test, but validation set. So you keep changing the validation set all the time and keep iterating this procedure, split and repeat. So statistical method of evaluating generalization performance. So you are training on these models and test on here. You're training on these data set and test on here. And you're training on these and test here. And training on these and test here. If you make a k equal 10, then you are splitting 10 different, like randomly shuffle the 10 different test data set and like 10 different training data set. And your role is the first like run, you are this amount is fold 1 was test set, and this fold 2 to 5 was training set. And fold 1 was training set, fold 2 was test set. And this, keep repeating that. And this was 80%, 85%, 81%, 90%, 92%. So you keep split test and training set randomly 5 times or 10 times, and then take an average. In that way, you will see what was true accuracy or true, more generalized accuracy of your model. So let me back to this formal definition. The more stable and thorough than using a split into a training and test set. Data is instead split repeatedly and multiple models are trained. Most common version is k-fold cross-validation, where k is specific number, usually 5 or 10. Okay? This cross-validation, for example, you repeat, you split and repeat, split and repeat, split and repeat, is a good choice of training a test set, but provide the sensitivity of the model, use data more efficiently. But it's really computationally demand because you keep randomly shuffle and train the model and test the model, validate the model. Okay, so it's not a model building, but really the cross validation is just to see how your result is good enough when you go to the final test set. All right, so this is all about the cross validation. I know somehow overwhelming, so let me have your questions on cross validation.
Please correct me, like the procedure for the test set and the training set is same, but we only changing the time span of the data set.
No, it's not time spent of data set, but let's say whatever you have 1,000, for example, let's go this example, the 700 and 300. So the very first run, you put this amount is 300, but the second run, you might want this 300 as a validation set, right? In the third run, you put this 300s as a validation set. And this run is validation set. And this one as a validation set. And the last one is a validation set. All different 300 combination on the splitting, training, and validation set to get the more generalized or more accuracy or error rate of your model. Does it answer your question? You were Zahid, right?
Yes, thank you. And I have another question is like the higher biasness is because of the error in assumption. So is always be a underfitting or can be a overfitting too? Like our assumptions can be like we are highly assuming something or sometimes can be we are under assuming. So it
Yeah,
always be a underfitting
it
or
is
can be
always be
overfitting.
the, yeah, I think it's underfitting. Yeah, based off my knowledge. And that type of your own error is, we call it variance, because you're too variant on your like data set. So it's very sensitive about your data set. And that kind of error that you just mentioned is variance.
Okay,
So
and sorry, it's
yeah,
Aksa. Zahid is
go
my
ahead.
last name. My
Mhm.
name is Aksa.
Oh,
Zahid is my
sorry.
last name. It's
Akshat,
okay.
okay. Yeah,
It's okay.
thanks for correcting me. Any other question here? I think this cross-validation process is the most important step, is the most important thing you have to learn, even before learning the new ML models. Okay? Because sometimes people having the falls in an error that they have a certain data set and they keep training and training and training model in the 700. And that is always good because you train on this data set and you test on this data set. That's always good. Computer works really well. But the problem is you will have really wild, your algorithm will go to wild, hidden data set or unseen data set. And to prevent that kind of error or really see the more reliable number on your errors or accuracy rate, that's why we split into training and validation and keep split and repeat for the k-fold validation, like 10-fold validation, cross validation, or 5-fold cross validation. Okay, so any question on chat, Tanner?
None yet. There was one question, but you had already answered it. I believe so.
Okay. Cross-validation. Everyone get the points or ideas? I saw that Daniel is here, Daniel Gomez. Do you think you got the cross-validation concept, Daniel Gomez? Or Holy, you guys are getting the concept of cross-validation?
Yes, I got it.
Okay. Sounds good. This is very important. If you're shy now, just feel free to contact me about the cross-validation. I really want to deliver. I mean, I think this is the most important parts you have to learn in this, this Friday session, cross-validation. The concept of cross-validation, basically. All right. Let's move on. The last portion before learning the ML algorithms, evaluation of classification performance. So let's say like how to evaluate your model. That's the main question, how to evaluate your ML algorithm model or ML models. So we call it confusion matrix for a binary target called positive and negative by convention. So there are 4 possible outcomes. Prediction, computer's prediction as a positive and negative, and actual positive and negative. If the prediction was positive and actual label was positive, then it's a true positive. If it's a negative prediction and it really was a negative, then true negative. If the prediction was negative, but the target was positive, then false negative. If prediction was positive and target was negative, then false positive. Okay? So let's move on. So here's whatever ML algorithm, and it detects either orange or not orange. So this is a confusion matrix. Note that it was a prediction on column, but now the prediction is a row, but it just switched. There's a true positive as 105, true negative as a 50, false positive as 10, false negative as 1. What is the accuracy? Can anyone come up with an idea to calculate the accuracy from this confusion matrix?
What's the question again?
Yeah, so what is the accuracy? How can you calculate the accuracy using this confusion matrix?
We can say accuracy, true positive all over total prediction.
Okay.
Percentage accurate.
Okay. Close, but not quite, right?
Would you have to include the true negatives as well?
That's correct. So from the computer perspective, the true positive and true negative, which is this diagonal line, is doing right job, right? It detect it was orange and it was orange and it was not orange and it was not orange, right? So 155 divided by the total is 165. 166 is your accuracy. 993.
93%.
Yeah. Yes. So this is how you can use the confusion matrix to calculate the accuracy. Okay. Any question? Quite straightforward concept, right?
Yes.
Okay. So before I conclude the session 1, really, this t-fold cross-validation is important. So let me do this. Oh, cross-validation. Is there any thumbs down here? So let me ask cross-validation. Yes, I know it. Please vote. I know this. Hey, Tanner, do you understand cross-validation from your end?
I think I'm learning with you on this, but I understand it some, yeah.
Okay, please vote on yes. How about Joel and Joseph, Holly, Aksha? See, Juan, you got the right number, 93%. Good. Okay. Keep increasing the number. 5. Kind of, I do feel like it's kind of checking the attendance now. Either you're just turning on the computer or not. But really, if you just logging in now and don't know what the heck going on, then just put no. Then I can explain the cross-validation to you again, because this is super important concept. No, okay. One no. Daniel. Okay. Yes, but it won't let me use emojis. Oh, okay. Because you are in a guest mode. Okay. Nice. Okay. 2 people. All right. Let me try again about the cross-validation. Yeah, I feel that, Daniel. All right. So there's a 2 types of errors. One is underfitting, like this figure, this function. This is overfitting, too sensitive about the data input. And we need to evaluate and improve the performance of a given model to balance between these bias and variance and error. So what we can do here is we need to split and repeat this concept. Let's say we got 1100 data points. That's input. Now you have to training set of, no, first you have to put 100 data points in a final test set. Final test set. This is a final test set. And this final test set means you put 100, you assign this 100 final test set. You never touch that. That's for final accuracy, estimate accuracy. Okay? And you have to divide your 1,000 data point into 300 here for the validation set and 700 data points in your training set. Now, if you learn the model out of this 700, keep all the time, then obviously the training error will decrease because you have a certain book and professor said that all the exam will be on this book. Then if you study pretty well, then you'll get the 100 points. So your error will go down. And your model, your brain is very complicated about that thing. But let's say the professors decide to give a question from outside of the textbook, which is this 100. And you might have some errors, right? It's outside of the problem bank or example bank that professor will provide you. To avoid that kind of situation, you have to have this 300 data set, split it, and keep training 700 and 300 all the time. So like here, first you have these amount training set and test set. Note that this is not final test set, but this is the validation test set. Keep changing it, changing it, changing it, and 80%, 85%, 81%, 90%, 92%, and take the average in that way and see how it improved or not, and see what was the best. In this way, you can evaluate, you can avoid basically this kind of error, but you are testing your wild data set with the keep, split, and repeat with the stratified, the training and validation splitting mode. Okay, so that's the cross validation, the main idea of a cross validation. It's super important in any machine learning algorithm development because it will like avoid or bounce between variance and bias. All right, I think I did enough on the cross validation. If you have any further question on the cross validation, feel free to let me know. All right. Before we move on to ML algorithms, anyone have any question on the first part? So your microphone, your microphone
sorry.
was, yeah, go ahead.
Do you hear me? Well, good.
So I think your microphone condition was not good. So
Did you
please,
hear me good?
yeah, I can hear me now.
Okay.
I can hear you now.
Just a question. This is related, or this is similar to sensitive analysis?
No, this is more on the cross validation, how to train and validate your model. I think sensitive analysis is really depending on what you want to do. But I think this is normal sensitive analysis now falls into this category. Was it?
Okay, got it. Yeah.
Okay.
Thank you.
Thanks, Juan.